Hello.
Hello. Hi.
Hi.
There you are. I wasn't sure if I heard your sound, but I got you loud and clear now. Are you still in Greece?
Yeah.
How's the experiments going? Hi, Brendan.
Difficult to get equipment.
Oh, I having
You
trouble
mean
getting
the one
equipment.
the one I'm trying to do in Greece. The one in Prague is moving forward.
Oh, which one is the ether on wind?
Excuse me?
Which one is the ether on wind experiment?
The one in Prague.
Yeah. All right. Well, that's exciting.
Yeah, it's just it takes time to build the device, so I'm just hoping they'll get it done soon.
Yeah, and sometimes take longer than originally planned, that's for sure.
Yeah.
Oh, neat. Hi,
So,
Justin.
has anybody done some work trying to simulate something in the meantime?
I was waiting to hear from David Johnson, and he never contacted me, so he must have been busy, I would expect. And I was kind of, I was considering maybe he was working on it, but I don't know. We'll have to discuss that with him maybe next week. Yeah. Do you have any sound, Brendan?
He doesn't have sound. I didn't
Here?
have any either in the beginning.
Ah, well, we can always chat if you need to, Brendan. Can you hear us?
He can use hand signals.
We can hear each other, but we can't hear you, Brendan.
I'll say hi to Brendan in the chat.
Do you understand what he's saying?
I talk amongst.
Write it in the chat.
Yeah. You never know. We might come to some great discoveries this way. Oh my. Can you type in the chat? Let me see if I go directly to Brendan.
Okay, perhaps we can use maybe he gets our message now. It's chat. Well, maybe he can't hear us if he doesn't know we're saying use the chat window.
No, he said he could hear you.
But he's not
I
typing
think so.
in the chat window.
And I've been sending some chat, so maybe he's replying.
I'll reply. So in response, Paul, I haven't done any simulations. I haven't done any of the computer stuff. I've been working on devices that put out that work with the vortices. That actually, because you can get using materials, like a crystal. A crystal, when it's built, it actually has a spiral structure that's when it's forming, and that basically spins the ether more, where you get a field from crystals. Materials and shapes also do the same thing. That's why you see the same thing in pyramids, particularly pyramids that have some crystal structure in them, but made out of granite, that type of thing.
Ah.
Hello. Ah, there he is. We were just wondering where you were.
Yeah, I sent you a message and said I wouldn't participate today, but I have time. I have a little time.
Good to see you, David.
Did you do anything with the simulation in the last week?
Well, I upgraded the memory here so I can run it. That's
How
what
much
I
memory
know.
did you put in? David?
I can now run it, and I can also share this environment over the internet if you want to do something. But the initial data is what of course I need to change, and also that thing about rotational stuff. I need to check that because I want to know the details before I add any terms.
Which rotational stuff? There was a whole bunch of stuff Brendan put out. I think
Rotational viscosity, was that the word? Yes.
rotational viscosity.
No, wait. No, it's not rotational.
Vortex.
Rotational diffusion, I think it was the term.
Rotational diffusion.
Yeah.
Yes. Yeah.
Well, that was the term, yeah, Brendan had put in his paper. Did you see the broadcast recording, Justin?
No, I didn't get to see it.
Okay, so you might not know. Maybe you know what we're referring to, maybe not.
But I did see a whole
Michael,
bunch
what were you? Oh no, Brendan, I think had suggested the idea of the rotational wave, that we could try simulating that first before we put in the Navier-Stokes equations. Now, did everyone read what he wrote up about rotational waves? We stimulate a plus and a minus pulse in two locations to start the thing rotating and see if it rotates.
So an external rotational force. Okay.
Yeah, sort of self-imposed initial condition, and then see what happens.
Sure, it sounds good. The rotational element is it's a core element, however we get it. Now, which environment are we talking about? We're talking about the equations that Pulver worked on, or are we talking about the open foam to do that in?
Let's see.
Or both.
Brendan, let's see. Looking at what you wrote here.
He's just saying that he hasn't responded to
that. I think we were going to try working with what Matt had done, probably in Mathematica. He didn't say in here what program he would use.
I checked a little on the JavaScript version, since it's a bit easier to run and doesn't require a license.
Well, use what David.
I agree with David that it makes sense to use the C++ version.
Which version was that, Justin? Oh, I didn't hear.
David mentioned a version that didn't require a license. Mathematica requires a license.
Yeah, the JavaScript version is free, but it's not written in a very intelligible way. It seems to be very much code there, so I haven't easily been able to understand that code.
You talking about the C++ version, or
no, JavaScript, the one which is put on the web page.
The web, yes.
Starburst.
The reason why I sort of pointed to the C++ because it's should be faster from a performance perspective than the JavaScript one.
No, because the JavaScript is one-dimensional and the C++ is 2 or 3.
Okay, I haven't done performance tests on the two. I haven't done performance tests on the two.
No, but what I mean is you just run on one dimension in JavaScript. And that's why it's faster. If we work with symmetrical.
Oh, okay, we're doing the same dimension, but to get rotation, you need 2 dimensions, right?
Rotation, that might make things more complex, but it's still centrally symmetric, so it should be possible to make a one-dimensional simulation.
I don't know how to get vertical motion in 1 dimension.
You get the component if you just check on the concentrations, radial dependence on the concentration, then it would be enough.
Isn't that an oxymoron?
What?
Rotation in one dimension? I don't know, whatever is the definition of oxymoron. I think it's impossible, isn't it? Huh?
You may get some property out of it, but I don't think you're going to see clear rotation.
You might be able to see some cyclic variation, you know?
What are we looking for here? If we have a rotating particle, like a sphere, and we just want to see the concentration variant, concentrations, then one dimension would be enough. But what are we looking for here?
We're trying to do the spin, so we'll need more than one dimension.
No, but what kind of physical properties are we, do we want to see in the simulation?
Spin. And
Yeah,
that's a big
well,
physics property for, you know, matter. And that's what we're trying to represent here.
Spin of the particle.
Yeah, some type of vortical behavior. And you know, I get your point that there might be features of vortical behavior in one dimension, you know, some type of cycle in the wave. But it, you know, we really, you know, 2 dimensions makes kind of sense for the rotation.
Or do we need 3 dimensions then if we're getting?
You can see rotation in 2, preferably 3, but you know, if we're starting, we're trying to make a simple experiment. Just, you know, while we're trying to work out our understanding of open foam, you know, run a simple experiment with some rotation in it, some way of creating rotation. And I think the experiment, 3 dimensions, the C++ code, you said that's 2 dimensions, 3 dimensions, I think even. So we could still try a 2-dimension one as the easy part to start.
By the way, Brendan did chat into the chat room that he was suggested using Mathematica first before the C++ ETD stepper. So I don't know if anybody saw that. I just thought.
Yeah, did
I don't know who has a mic.
we all saw this, right?
Excuse me?
Isn't Mathematica also one dimension?
This is what Brett brought up.
I haven't read through it yet. I read some of the other ones, but I haven't gotten to this one yet.
So now, what our discussion last week, I thought we were going to be trying out Mathematica, but that software you're referring to, David, I mean, I went to that web page on Starburst, and I never happened to see any code, so I'm not sure where you access the code for that.
No, you can take the source code. Everything on the web with JavaScript, you have the source code in the browser.
In the browser, you just scrape it out of the browser.
But it seems to have been composed by some. It doesn't seem to have been written by a human, that source code. It seems to be automatically generated, so it was not easy to read. Maybe we can ask Matt Palmer to put it on GitHub instead.
But there's only 1 dimension in that. But the C++ code, which he has shared, I think at the GitHub location, that's 2 or 3 dimensions.
You can do all 3 dimensions, I thought, in C++ code.
How many
We
dimensions?
should probably put all 3 dimensions up, since there might be some variability in, or at least maybe we can assume it to be symmetrical. What do you call it?
Who has a license of Mathematica?
Actual symmetry.
I do. I have the basic version,
Anyone
but
else?
I don't. I have it on my laptop. The disk is probably in the U.S. I don't have it here.
Yeah. So we've got 1 license between the 5 of us.
What about you, David? I thought you might have had a Mathematica.
Pro version or whatever.
I mean, if I
only
upload the program,
I've run it before, but I only have the temporary license.
could I share it with somebody, like just my program, to email it to somebody to use?
Absolutely, you can loan it.
Is it just the 1 file, the one in the application folder? It doesn't need anything else, just that at one, right? So I could put it like, I mean, it's pretty big. It's like 3 gigabytes or something, 4 gigabytes. So I suppose I could put it in Dropbox, do it that way.
Yeah, that would make sense. You can put in Dropbox and one person use it at a time. But typically the licensed server tools, you know, when you try and log in, it goes and checks. So it'd be one person. And I think you'd have to share a key or something.
So who would like to use it? So who should I be sending it to? Is somebody going to be running this, or everyone will be running?
Somebody said they thought we were going to do it in Mathematica. Was that Michael? Was that you? Did you run that?
Isn't it? I thought that's what you had mentioned last week, David. And then Brendan, he just chatted that he thinks Mathematica is one. Well, he's asking sort of, is it 1, 2, or 3D? So I'm guessing it'd be all dimensions.
When I saw the code when I ran it, I think it was only 2D when I ran it, but that was some years ago, so I don't know what it is now.
Okay, well, who has that?
I forgot where I got it from. I thought it was, you have to check back in my records. But I think there is a link for the C++ code. Looks like the Java you can scrape. The Mathematica, I probably have something somewhere in my files because I know I ran it. Probably have a Mathematica file.
Yeah, if you ran it before.
If I got it from originally, there might be an update there. Yeah, it's just that Matt left off with the C++ version. That was the last thing that he did. So it may make, and I think somebody mentioned there were 3 dimensions in that. So it may make sense to pick up from where he left off, because you know, I think that the need to do all the licensing with Mathematica was an issue for him too. I'm not sure, and so and he may have found that he had more freedom with the C++ code. So,
if I remember correctly, it's been a few years, but you can edit the C++ code and vary the dimensions.
Yeah, I would pick up from where he left off and go with the C++ because that's, you know, he moved from Mathematica, then JavaScript, and then he moved to the C++.
So then we won't be doing Mathematica then, is that?
No, it's by choice of whoever's going to pick that specific piece up. You know, if we're going to do you know, what I was talking about, you know, having a build for everybody to use, it's going to be licenseless, so it would be like C++ code, and so it would be an environment that had all the free tools associated with that, so that everybody could pick up and work with it. I just think that, you know, when we have such tools that are free to everybody, you have more people working at it once, and there's more shared stuff that you can do.
So Brendan, he said in the chat that he thinks the x-axis in Mathematica represents 1D, but the concentration of x, y, g is 1, 2, and 3D. So,
I don't know why I'm not seeing these messages come up in my chat.
yeah, actually, you know, Brendan, if you can hear me, if you want to send these text messages to all the group members, you want to choose all in the chat, but because I think right now you're sending them just to me privately.
Yeah, it's
I don't see anything you're saying.
Yeah.
Yeah, there's an everyone setting.
It's because I sent one to Brendan privately to see if I could get his attention. Yeah. Yeah. So I was wondering, are we still planning, intend to run anything on the 2 solitons like we had discussed last week?
Do we have a list that somebody's maintaining of the experiments that we want to do in order? You know, I had a list of plan of how to create the shared environment, but, you know, we can have a list of which experiments we want to do first.
Yeah, last week, I mean, we had discussed the torsion element and that Brendan was discussing, but I don't know if we actually had discussed running that. I thought we were discussing running the two different solitons. So I thought that's where we're at by my memory.
Oh, yeah, that's right. That's definitely one experiment.
Yeah. So, and then that was done in Mathematica. Is that right, David?
Pardon?
The two, the experiments where Matt had ran a soliton with a G gradient on it. That was in Mathematica because that was running 1D, I believe. Is that right?
Yes,
Yeah.
very likely, yeah.
Okay. So, I mean, will we need Mathematica to repeat that again? Or something similar to that?
Yeah, you need the Mathematica to do that one, unless you reprogram it on the C++.
Yeah, I'm not sure if how it would work out just now without having looking into it yet. What do you think, David?
This was a long time ago, but I think I rewrote that in JavaScript and put it on the web page. Yes, if you see my posting from the 3rd of March, that is a link to the Mathematica notebook file. And that's a one-dimensional solution.
Okay, and that's the one where you just scrape it off of the web page to get the code we were just talking about, right?
Yeah, I don't have Mathematica. I have an old version 6 something, and I don't bother to install it. So I don't really know what that Mathematica file is doing.
Hmm.
But
Okay, so he used a JavaScript for you believe Matt used a JavaScript for the 1D G acceleration. Is that what you're saying?
Yeah, from the March 3rd, yeah. That was also the one that was demonstrated here last meeting, I think.
Okay. Well, then we have that code, don't we?
The C++ you're talking about?
I think David was mentioning the JavaScript.
Oh,
Yeah, the JavaScript version is on, you can get it on the page directly.
Okay, but that was the one that was sort of hard to read though, right?
Yes, it's
Yeah.
a very big file.
Hmm.
Maybe we can mail Matt and ask how to get that. But first is to really understand what we need to get out. I'm thinking if maybe two-dimensional solver is enough here. If we keep some kind of axial symmetry, then 2D would be sufficient. But it would require more modeling and rewriting also.
Okay, so I'm just trying to take some notes here. We've got, I don't know if you can see my screen. Yes, no?
yep.
I can see it.
Okay, so we've got 3 different, okay, so we're talking about experiments. I hear this was one of them where we're talking creating rotation via alternating external ether forces on different XY dimensions. Okay, and then Michael, you indicated another experiment you thought we were going to be doing.
Right. It was I proposed it last week, and it was essentially 2 solitons separated from each other, And did you see the email I mailed out with some suggested?
I saw a lot of really interesting stuff going back and forth, but I didn't have a chance to get into it in detail. I was really excited to see all that neat stuff.
Right. That's okay. But I had sent out an email and with some parameters. Do you see that, David?
No, I have been too busy to check those mails.
Okay. Well, last week we had a discussion of maybe, you would need some starting parameters. So I came up with something, as a starting point. It was an email. If you need, I can re-forward it.
I'll look in our records. I'm sure I have it.
Okay.
I know I saw stuff from lots of people. So describing it as two solitons separated in what way?
Well, let me. I might need to forward that email to you, but I was thinking that, originally in the presentation last week, we considered that it may need some relative motion, but I was thinking, just to keep it simple, it's possible that if the two solitons were seated and at a distance from each other, but still in a proximity where they could interact, they might actually be able to interact with each other enough to where they induce a velocity themselves. And
not rotation, just velocity.
Well, it's possible that rotation might actually evolve from this. I was going to bring that up a little bit later, but it's possible that just the motion towards each other could evolve as they're being seated. And but the reason why I say that is just the simplest case is just two solitons being seated at a distance.
Yeah, you talked about this.
And then if nothing happens, then we could think about including a velocity term. So pretty simple, straightforward, relatively speaking.
All right, so these are the experiments, and then looking to Mathematica. I don't know how you want to describe it. There's a license cost.
Well, I'm not sure if we're gonna need to use Mathematica or not.
I think. The question is, okay, so each one of these different options has different tools or different properties that would say why we would want to use it. In this example, we have the code. Open source,
right?
Free, can include, build, that share, cross group. I'm just putting features down, so we know what the advantage and disadvantage of doing it one way or another. So when we do evaluation, it becomes obvious why we're choosing one and which one we should choose. So the JavaScript, we don't, source.
Sounds like the JavaScript is available, but it might be hard to work with.
No.
Yeah, we could as well use the C++ three-dimensional version to even if it's takes a while longer to run, we have that time.
So there's a 3D version?
Yeah, the C++ is default 3 or 2.
2D and 3D version.
And I'm not sure. Matt did some algebraic operations on the equations in order to simplify things, and that might make it a little more difficult to add terms to it.
Well, yeah, all I have right now is the C++ code, but I guess I could get the JavaScript. And I don't have Mathematica, but I might have
it would be so much easier to configure and do things like that if we could go and use web-based software.
You mean the C++, or are you talking about something else? Web-based? We're talking about like putting this on the web-based like the cloud?
Yeah, but not on the current.
Could you repeat that, David?
I think we initially have to run the C++ version and maybe later change that. But it would be the easiest and fastest thing to do, to just make the adjustments in the C++ code.
Mm-hmm. If I remember correctly, the only thing, it was actually pretty easy to make 1D and 2D simulations in it, but he didn't write any of the code for displaying it graphically. And it was only for 3D. So, you know, either way, it's going to require a little bit of
So
programming.
you're saying the graphical display is missing for 2D?
I think 1D and 2D, if I remember correctly. But it's been a few years.
But available.
Mm-hmm. But I think the raw data is available though
3D.
from the output.
Okay,
it should
and the
be
3D isn't that just concentrations or?
Yeah, the 1D.
The 3D, you said that there is some visualization for the C++.
Does it have rotation? Did you ask?
No, I was asking if the visualization for the C++ code, the 3D version, was based upon concentrations, or how was it 3D?
Yeah, it plots profiles of all the different concentrations in 3D.
Okay,
I believe so.
because because you can have a 3D view, but then you have to have a concentration in that, so that means you would have a color code or something like that indicating the concentration.
Yeah.
Okay.
Yeah.
Okay, so we described the C++ version. I'm just gonna put down, we understand this version better because we were able to describe it better. Do we have similar descriptions for the other two?
For the JavaScript and the
And the Mathematica, can we just, you know, put as many bullet points for
well, I mean, now, Dr. Violet, why is it that you believe that Matt used Mathematica? Which runs experiments were those for? Do you remember specifically?
What did Matt do with Mathematica, you're asking?
Yeah.
I think he's trying to get understanding what was the motivation. I already mentioned my understanding, which is just an outsider because I was just watching which one is being used when. That he started with Mathematica, and then he found that it was constraining him and, you know, sharing, and that then he went to the JavaScript to share it on the web, and then he went to the C++ because he was able to do other types of computations he couldn't really do in the Mathematica. He felt constrained in the Mathematica. And I don't know if that's true or not, but that's what I got the feeling in watching things. Paul might have likely has a better understanding of why the different systems were used. Why was Mathematica used first in JavaScript?
Most of what we did was in Mathematica. And then the simulator on Starburst website was the last thing he did. So anybody could do their own experiments, so to speak. But it's restricted.
When you say the simulator, you're talking about the JavaScript one or the C++ one?
It's only one, there's only one simulator on the Starburst Foundation page. You know the one I'm talking about?
Yeah, David had linked to it. Or I
I
guess
can
Somebody have a
Yeah,
link?
it's a link on the mark, start the mark there.
on Facebook.
I can open it up and take a look.
Just
Let's
paste
see.
it in the, because I put it in the notes, so if you could paste it in the chat.
Let's see. Um,
I'm not sure how to see the chat here. There, maybe. Yes.
okay.
All right.
And I'm not sure how to share the screen because all the buttons are gone.
Okay, I'm going to stop sharing and let you share.
Let's see. I could do a search for.
We just got a note from Brendan. He said the meeting will end in 10 minutes and he will start a new one after. And I'll post it in Facebook.
Close it
Here's
at
the
5 minutes.
simulator. I found the simulator.
Is
Is there a way I could share the screen?
Yeah, you go down to the bottom of your screen and the button should be there. You should have a green button, share now.
Yeah, the whole page has disappeared. All I'm seeing is your 4 pictures.
If you scroll your cursor very down to the bottom middle, and you're going to see some things pop up, and there should be like a share button there in green.
No, that page is missing for me.
Oh, okay. Well, that might be because you're sharing.
I'd have to quit somehow from and come back in the conversation, I guess.
Anybody else have an idea where he is?
I don't know how to hang up.
I notice sometimes, you know, there's like more than one Zoom page. You know, it might be on in a different tab.
Let me see. Here's the page, the Zoom page. Maybe I just click on the page, huh?
I'm not sure. Zoom gets me from time to time too.
Well, I know. I'll just click on the link that you had given me. Let's see. Here it is. Okay.
Oh yeah, Brendan says quit and then restart the share. If that's might be helpful.
Oh, I guess it's not working. So there's no way I can share my screen. But if you go to the website, starburstfound.org, and put in the search engine Model G, the first thing that comes up is the simulator.
Okay, yeah, that'll help.
And you can plug the values in there. But we can't use that to do our experiments because it's very restricted.
Mhm.
I mean, how are we going to put 2 particles to make them attract? I don't see a way to do that.
I thought we were going to do Mathematica.
So here's the code that was put out in 2014. I'll go ahead and share.
There's some experiments described there in the simulation page.
So this is the GitHub stepper code. I believe this is the C++. You know, you got the CPP, C++. And you know, he talks about 1, 2, 3 dimension space. So that the requirements are open source stuff. Plots, that's open source, UV, open source, all that stuff. I think it's Fast Fourier or whatever.